Hello, everybody. Here we are, 2.1. What is a power? I left some blanks, I think, on your sheet, so let's just make sure you fill it in as we go along. The first one, we start with some glossary terms. Power, so power is a base number. There we go, highlight that, with an exponent. So, for example, 5 to the power of 3, where 5 is the base and 3 is the exponent. So let me draw this again. If we had 5 to the power of 3, the whole thing is called the power. This big number here is called the base. And this little number that's raised above it is called the exponent. And we'll go over that again, but there it is. And so some notes. So a power is used to represent repeated multiplication. I think we got to highlight that. Basically a shortcut, right? It would take us a long time all the time to have to write 5 times 5 times 5. So it's easier for us to write 5 to the power of 3. And sometimes we get into really huge numbers. So this is just a kind of quick way of doing repeated multiplication. So instead of writing 3 times 3, we can write 3 to the power of 2. This exponent is telling us how many times the base is being multiplied by itself. So the bigger number in a power, the 3, is called the base. Highlight there. And it is the number being multiplied by itself. The smaller number in the power, the 2, is called the exponent. And it tells us how many times the base is being multiplied by itself. Okay, so in the case of 3 to the power of 2, this is what's being multiplied, and this is how many times. So 3 times 3. 3 is being multiplied by itself 2 times. If a number does not have an exponent, like just 5, like, just the way we're used to seeing numbers, just like 4, there's always an imaginary 1 right there as an exponent. So it reads 5 to the power of 1, or in my example, I put a 4. So it simply means that the 5 is not being multiplied by any other 5s. Okay, so the invisible exponents are helpful later when we get to polynomials and you have an x. We need to remember there's an imaginary 1, but I won't get too ahead of ourselves. So for example, here we go. We got 5 times 5 times 5. That's 5 to the power of 3. The base is 5 and the exponent is 3. This one, I think I've got an error. We got 7 times 7 times 7 times 7 times 7. I think that's only 5 times, so it should be 7 to the power of 5. The base is 7, and the exponent is, that should be a 5. So the base is 7. I think I've highlighted that. Powers of negative numbers, here's where it gets a little tricky. So if a power has a negative base in brackets, let's highlight that in brackets, we treat it the same as a positive power. So for example, if we have in brackets negative 3 to the power of 4, we need to repeat the negative part each time. So it's negative 3 times negative 3 times negative 3 times negative 3. It's very important that we pay attention to if there's brackets or not. That means that our base, in this case, is negative 3. Okay? Let's move on. So, however, if the base is negative but does not have brackets around it, so I think I highlighted here, but does not have any brackets around it, we do not include the negative each time the base is being multiplied by itself. So let's look at an example right here. So we don't have brackets, we just have the negative 5 to the power of 4. That means we don't repeat this negative when we're doing our repeated multiplication. So it's actually just the negative on the outside and then 5 times 5 times 5 times 5. So the negative is not in each of them. It just occurs once. It doesn't recur as part of our repeated multiplication. Okay, so actually I should cross that out. So it's not like that. So finally, I'll just do a few with you. Evaluating, or that kind of means solving. So solving positive and negative powers. So to evaluate a power, we simply multiply the base by by what the exponent tells us. So here we've got 3 to the power of 2. That means we have 3 times itself twice. 3 times 3 is 9. Here we have 5 to the power of 3. That means we have 5 times itself 3 times. 5 times 5 is 25, and 25 times 5 is 125. Next, we have 2 to the power of 3. That means we have 2 times itself 3 times. So 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. Next, we have a -4 in brackets to the power of 2. So this negative part is repeated. And if you'll recall, we have -4 times -4, and negative times a negative is a positive. So -4 times -4 is positive 16. Next, again, we have in brackets the -3. So the -3 is our base. We need to repeat the negative each time. Okay? So that's really important. I think that's when people can get tripped up. So make sure you take an extra second to pay attention when you have a negative base. So -3 times -3 is a positive 9. And a positive 9 times a -3 is going to give us -27. Next, we have not in brackets, negative, and then a 5 to the power of 3. So just the 5 is our base. So we don't forget our negative. That goes with us. But then we have 5 times 5 times 5. We found out up here that that's 125. But we can't forget our negative comes along with us. So it's negative 125. Next, last one, kind of tricky. We have a -4 as our base, but then we also have a negative on the outside. So let's do the -4 as the base first. So -4 times -4 is a positive 16. And then 16 times a -4, oh, I think this is 64. Is that right? 16 times 4 equals, 64. But we have a positive times a negative, so that's going to be a -64. But then we still have from the beginning this negative. Let's bring it over here. So now we have -64. You could leave it like that, I guess, or we could show that as a positive 64. Remember, if you subtract a negative, it's like adding a positive. So you could evaluate it like that. Okay, I'll give you the textbook questions I want you to do. Thank you so much.